Yo, it's me, the one and only Sigma. And in this video I'll be doing practice mastery for chapter 2 factorization and algebraic fractions because I can't leave the other chapters without example questions.
I bought a property in Egypt, and what they do for you is they give you the property.
Problem 1, area of shaded regions. You can find the area of a rectangle by multiplying its length by its width. A. The shaded region is a rectangle with length a plus 1 and width a. Therefore, the area is a plus 1a. B. The shaded region is a rectangle with length 4x plus 3 and width 4x. Therefore, the area is 4x plus 3 4x. Problem 2. Expanding algebraic expressions. To expand an expression, you multiply each term outside the parentheses by each term inside the parentheses. A. 3x plus 2 equals 3x plus 6b, 48x, 3, equals 32x, 12c, 2a plus 5, equals 2a plus 10d, p6p, 8, equals 6p2 to 8pe, r slash 8 choose, 8, equals 1 slash 4rs plus rf, minus 2pr, 2pq, equals 2pr plus 4pqg, 35bc, 6, equals 15bc, 18h, 72f plus 3e, equals 14f plus 21e 8 grams 2 plus gh, equals 16 grams plus 8 grams carat 2 hours. Problem 3. Expanding algebraic expressions. To expand a product of two binomials, you can use the FOIL method. A plus 1a plus 2, equals a 2 plus 3a plus 2b, x, 5x plus 4, equals x2, x, 20c, 2 plus m5, m, equals 10 plus 3 meters dash square meter d, 3p, 2 4p, 1, equals 12p2 to 11p plus 2e, 3r, 2 4r, 1, equals 12r2 to 11r plus 2f, 2r plus s 4r, 3s, equals 8r2 to 2rs, 3s 2g, 2d, 1 slash 2b 3d, 1 slash 2b, equals 6c2 to 2db plus 1 slash 4b 2h, r, 3s 2 equals r2 to 6rs plus 9s 2i, 4e, 3 2 equals 16e2 to 24e plus 9. Problem 4, simplifying expressions. To simplify an expression, you combine like terms. A, 5b plus 3, plus 4 3b, a, equals 17b, 4a plus 3b, 3 4 meters, 5 mn, 2 8 meters plus mn, equals 4 meters, 17 mnc, h, j2 to 2 hours 3 hours, 3j, equals minus 5 hours carat 2 plus 8 hj, j2d, x plus yx, y, plus 2xx plus 2 years, equals 3x2 plus 3z, y2. Problem 5, find the area of the shapes. The area of a rectangle is found by multiplying the length by the width. A. The shaded region is a rectangle with length 2p3 and width p. Therefore, the area is 2p3p or 2p23p. The area of a triangle is by multiplying the base by the height and then dividing by 2. B. The shaded region is a triangle with base 3 years minus 2 and height y1. Therefore, the area is 3 years minus 2 y1 slash 2 or 3 years carat 2 to 5 years plus 2 slash 2. C. The shaded region is a rectangle with length 5x plus 2 and a width 2x3. Therefore, the area is 5x plus 2 2x3, or 10x to 11x6. D. The shaded region is a triangle with base 4w2 and height 2w. Therefore, the area is 4w2 2w slash 2 or 4w2 2w. Problem 6. Adila is 2 years younger than Kaihi. Kaihi's father's age is the square of Adila's age. If Kaihi is p years old, calculate the total age of the three of them. Express your answer in the form of an algebraic expression. The square of a number is that number multiplied by itself. Adila is 2 years younger than Kaihi, so her age is p2. Kaihi's father's age is the square of Adila's age, so his age is p22. The total age of the three of them is p plus p2 plus p22. Problem 7. The tabletop is a rectangular shape with length 5x2 meters and width x plus 2 meters. Mr. Philip wants to put a piece of glass over the tabletop. The section of the tabletop not covered with the glass has a width of x3 meters. Determine the area of the tabletop that is not covered in the form of algebraic expressions. The area of a shape that is not covered by another shape is found by subtracting the area of the covered shape from the area of the original shape. The area of the tabletop is 5x2x plus 2. The area of the glass is x3x plus 2. So, the area of the tabletop that is not covered by the glass is 5x2x plus 2, x3x plus 2. Problem 8, determine the length of LM in terms of y. The length of a line segment is the distance between its two endpoints. In the given triangle, we are asked to find the length of the side LM. We can use the Pythagorean theorem to solve this problem. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse, the longest side, is equal to the sum of the squares of the other two sides. In this triangle, KL is the hypotenuse, and KM and LM are the other two sides. We know the lengths of KL and KM in terms of y, so we can use the Pythagorean theorem to find the length of LM. Here's how we can do it. Write down the Pythagorean theorem. KL2 equals KM2 plus LM2. Substitute the known values. 7 years, 3 2 equals 4 years, 1 2 plus LM2. Expand the squares. 49 years caret 2 to 42 years plus 9 equals 16 years caret 2 to 8 years plus 1 plus LM2. Simplify. 33 years caret 2 to 34 years plus 8 equals LM2. Take the square root of both sides. LM equals SQRT. 33 years caret 2 to 34 years plus 8. Therefore, the length of LM in terms of y is SQRT. 33 years caret 2 to 34 years plus 8. Problem 1. This problem asks us to find the greatest common factor, HCF, of different pairs and groups of terms. Remember, the HCF is the largest factor that divides all the terms evenly. At 8 years and 12 years, both terms have y in common, and they can both be divided by 4. So, the HCF is 4 years b, 2b and 3b, both terms have b in common. The HCF is b, c, 3w and 5w2, both terms have w in common. The HCF is w, d 10 square meters and 15 mk, both terms have 5 and m in common. The HCF is 5 meters, e, 5bc, 2c2, and 3cd. The only common factor in all three terms is c. The HCF is c, f, 4a2b, 8b2c, and 6bcd. The common factors are 2, b, and c. The HCF is 2bc. Problem 2. This problem asks us to factorize the given expressions. This means we need to rewrite them as a product of simpler expressions. A. 5e plus 10, we can factor out a 5 from both terms, 5e plus 2. B. 2ab, 8a2, we can factor out 2a from both terms, 2ab, 4a. C. 3ab plus 6a2b, we can factor out 3ab from both terms, 3abc plus 2a. D. 4x, 12x2, we can factor out 4x from both terms, 4x1 to 3x. E. F plus f2 plus fg, we can factor out f from all three terms, fe plus f plus g. F. 2x2 to 4z plus 6wx, we can factor out 2x from all three terms, 2x minus 2 years plus 3w. Problem 3. This problem deals with factoring difference of squares. This is a special pattern where we have the difference of two perfect squares. A. b2 to a1, this is the difference of two squares. It factors as b plus 9b, 9. B, a2, b2. This is also the difference of two squares. It factors as a plus ba, b, c, x2 to 1. This is the difference of two squares. It factors as x plus 1x, 1. D. 16 years caret 2 to 49. This is the difference of two squares. It factors as 4 years plus 7 4 years, 7. E. n plus 3 2 to 16. This is the difference of two squares. It factors as n plus 3, plus 4m plus 3, 4, which simplifies to n plus 7m, 1. F. 4x, 1 2 to 9, this is the difference of two squares. It factors as 2x, 1, plus 3 2x, 1, 3, which simplifies to 2x plus 1 2x, 5. Problem 4. This problem involves factoring expressions with three terms, There are different methods to factor the problem. A. x2 plus 9x plus 14, we need to find two numbers that add up to 9 and multiply to 14. These numbers are 7 and 2. So, it factors as, x plus 7x plus 2. B. x2 plus 7x, 18, we need to find two numbers that add up to 7 and multiply to minus 18. These numbers are 9 and minus 2. So, it factors as, x plus 9x, 2. C. x2 to 5x, 24, we need to find two numbers that add up to minus 5 and multiply to minus 24. These numbers are minus 8 and 3. So, it factors as, x, 8x plus 3. D square meter plus 11 meters, 26, we need to find two numbers that add up to 11 and multiply to minus 26. These numbers are 13 and minus 2. So, it factors as, m plus 13m, 2. E, y 2 to 2 years, 15, we need to find two numbers that add up to minus 2 and multiply to minus 15. These numbers are minus 5 and 3. So, it factors as, y, 5y plus 3, f, k2 to 8, k plus 16, we need to find two numbers that add up to minus 8 and multiply to 16. These numbers are minus 4 and minus 4. So, it factors as, k, 4k, 4, or, k, 4 2. G 2 square meters to 11 meters, 6, this trinomial has a leading coefficient of 2. We can use the AC method or trial and error to factor it. It factors as, 2 meters plus 1 m, 6. H, 9f2 to 12f plus 4, this is a perfect square trinomial. It factors as, 3f, 2 pi 2 square meters plus 4 meters, 16, we can first factor out a 2 square meter plus 2 meters, 8. Then, we factor the trinomial inside the parentheses, 2m plus 4m, 2. J, 2x2 to 5x, 7. This trinomial has a leading coefficient of 2. We can use the AC method or trial and error to factor it. It factors as, 2x, 7x plus 1. K 12 years caret 2 plus 8 years, 15. This trinomial has a leading coefficient of 12. We can use the AC method or trial and error to factor it. It factors as, 4 years, 3 years plus 5. I, 5p2 plus 6p, 8, this trinomial has a leading coefficient of 5. We can use the AC method or trial and error to factor it. It factors as, 5p, 4p plus 2, and minus 5 square meters to 6 meters plus 8. We can first factor out a minus 1 5 square meters plus 6 meters, 8. Then, we factor the trinomial inside the parentheses, minus 1 5 meters, 4m plus 2, n, 3p2 plus 8p, 4. We can first factor out a minus 1 3p2 to 8p plus 4. Then, we factor the trinomial inside the parentheses, minus 1 3p, 2p, 2. 6x2, x plus 15, we can first factor out a minus 1 6x2 plus x, 15. Then, we factor the trinomial inside the parentheses, minus 1 3x plus 5 2x, 3. Problem 5. This problem involves factoring expressions with 4 terms. One common technique is called grouping. A, PQ, QR, PW plus RW. Group the terms, PQ, QR, plus, PW plus RW. Factor out common factors from each group, QP, R, WP, R. Now, we can see that, P, R, is a common factor, P, RQ, W, BX2 plus Z plus 6 years, group the terms, X2 plus Z, plus, 6x plus 6 years. Factor out common factors from each group, xx plus y, plus 6x plus y. Now, we can see that, x plus y, is a common factor, x plus y x plus 6. C, 3ab, 9ad plus bc, 3cd, group the terms, 3ab, 9ad, plus, bc, 3cd. Factor out common factors. Problem 6. We are given a rectangular floor with a rectangular carpet placed on it. A. Calculate the floor area that is not covered by the carpet. The total floor area is given by length times width, 3 meters 2 meters, equals 6 square meters. The area covered by the carpet is 2 meters, y plus 2m equals 2m plus 4 square meters. Therefore, the area of the floor not covered by the carpet is 6 square meters, 2m plus 4 square meters, equals 6 square meters, 2m minus 4 square meters equals 2 square meters, 2m. B. Felisa wants to cover the whole floor area with a carpet of that size. Determine how many pieces of carpets would she need if the value of y1 equals 2. When y equals 2, the area of the carpet is 2 meters, 2 plus 2m equals 8 square meters. The total floor area is 6 square meters. To cover the entire floor, Felisa would need 6 square meters, 8 square meters equals 0.75 pieces of carpet. Since she can't use a fraction of a carpet, she would need 1 piece of carpet to cover the entire floor. That is all for the video because this chapter has too much questions for subtopics, so I'm going to make this in the next part. Don't forget to study for our beloved Shine Factory, and we need to surpass the Temu Factory. Okay, bye Sigmas.